We're going to go into our heavy-duty engine dyno. So here we're testing a Cummins X15 engine. It's a 15-liter engine. In addition to measuring the emissions with our lab, we're also going to be measuring it with the PEMS for engine out. And as I said earlier, we have an APC, and so we're going to be doing particle number measurements on this as well, in addition to a bunch of other particle number measurements with CPCs and catalytic strippers and other stuff that we have in-house and in use. So this lab is very unique. These, well, not unique in the sense that they don't exist at OEMs, but it's designed to be a certification lab. We control the fuel temperature and fuel pressure up to the engine. We also control the intake air at the requirements by the CFR. We actually control the water temperature and the charge air temperature. And in addition, in the back corner, we control the radiator temperature, and we have a big cooling tower outside and a big air conditioning system outside for that. All of that is to make sure when we run this engine, we're running it under very similar conditions across the country. This is how an engine is certified. It's certified on a stand. A vehicle is certified in the chassis dyno, what we saw earlier. So this has to be set up well. And some of the things we have to require support from OEMs. So one of the unique things is getting these wire harnesses to work. Nowadays, wire harnesses are being made by third-party companies. So when you tell them what engine you have, you can actually order a wire harness, and it gives you all of the features necessary to make this engine run on a stand, so you're not guessing at stuff. There's a lot of sophisticated controls in these engines. It's not something you can just do on your own. We did have a project about 2 years ago where we pulled engines out of vehicles and put them on dynos. That is very hard to do, but we were able to get it to work on a Volvo engine and also on a Detroit diesel. This is a Cummins. One of the unique things about technology since 2010 is the SCR. Over here is an SCR setup. In addition, we have the urea tank down on the ground over there, and this is to support controlling the exhaust for this engine. One of the important things is to make sure that the distance between the engine and the catalyst is very similar and insulated like it is on a vehicle. So we purchase parts for an on-road vehicle to supply that connection. So the heart of an engine dyno is the dyno itself. This is a DC electric dyno, so we're able to follow transient tests. This is what loads the engine. So when the engine is spinning and trying to put power, the dyno absorbs that power. And it's all integrated into the test cycles, and there's automation. So when we're done with the test, we can validate that the target was meant to the actual. And those are some of the things that you do. In addition to that, you calibrate the torque sensor at least once a year, you do linearities on it, and then you check all of your fluids and temperature sensors in the system.